Let's do another example using the addition rule. Let's suppose that we have some dogs and all are either brown or white. 30% of the dogs are outdoor dogs, 40% are brown, 1/3 of the outdoor dogs are white, and half of the brown dogs are indoor dogs. Now, we're not told how many dogs there are altogether. And in cases like this, the best thing to do is to construct a table. What all do we know about these dogs? Some are indoor dogs, and some are outdoor dogs. Some are brown, and some are white. So we start then by making a table and putting a category for each thing we know about them. And then we might put a total row and a total column. And in cases like this where we don't know anything about how many there are, and we know something about some of the proportions, a good thing to do is to assume a total. And it is a good thing to assume this total as a power of 10. And the reason for that is because the percentages are very easy to work with when we use a power of 10. Like, for instance, let's assume that we have 100 total. We're told that 30% are outdoor dogs. So for this category outdoor, 30 of them, 30 out of the 100, 30%, are outdoor dogs. That leaves 70% to be indoor dogs. We're told that 40% of them are brown. So if we had 100 total, we'd have 40 brown ones. If we had 40 brown ones and 100 total and all are either brown or white, then that means that 60 of them would have to be white. We're told that 1/3 of the outdoor dogs are white. We have 30 outdoor dogs, and if 1/3 of them are white, that means we have 10 white outdoor dogs. If that's the case, then we have 50 indoor dogs that are white. We could finish the table out from here. We're given a little more information that might help us. It says that half of the brown dogs are indoor dogs. Okay, well, there are a total of 40 brown dogs, so that would be 20 indoor dogs, half of them, which does give us 20 plus 50 equal to 70, and that means that we would have 20 here to add to 40, and 20 and 10 is 30. So our table closes up real nicely, and now we could answer probability questions from this. Like, for instance, we might want to know if we were to select a dog randomly, what would be the probability that we would get a dog that is either white or an indoor dog? Well, using the formula for addition, we could say that this is equal to the probability that we would select a white dog plus the probability that we would select an indoor dog minus the probability that we would select a dog that has both attributes, a dog that is both white and an indoor dog. And we can get all this information from the table. We need to know then the probability that we would select a white dog. Well, there are 60 white dogs out of 100, so that would be 0.6. Then we would need to add to that the probability that we would get an indoor dog. There are 70 out of 100, so that would be 0.7. And we can already see a problem here. 0.6 and 0.7 add to more than 1, and we can't have a probability that is greater than 100%. So there must be something that's going to be subtracted out, and that would be all of the dogs that have both attributes because they're added in twice now. Okay, so dogs that have both attributes, they are white and indoor dogs. Well, there are 50 dogs that are both white and indoor dogs. So this then would cause us to subtract 0.5. So now we have 0.8. So the probability that we would select a dog that is either white or an indoor dog would be 0.8, or 80% of the total. Now, another way we could see this is just by looking through here. How many out of this table have one or the other of these attributes, looking at each cell only once? Here's one that matches the indoor attribute. Here's another one that matches the indoor attribute. And here is one that we haven't counted yet that matches the white attribute. And adding this up, we'd have 80 out of the 100 for 0.8.